Alright, so for today we are going to learn another special type of discrete random variable other than binomial that we learned previously. Alright, so for today's lesson we are going to learn the geometric distribution. Okay, so again it is another special type of discrete random variable. Alright, so we learned two types of distribution here. The first one is binomial in this chapter that we learned earlier before, and after that from now it is geometric distribution. Alright, so first, of course, you need to know to differentiate these two distributions. Which one belongs to binomial, which one belongs to geometric. Right, so I think binomial, I roughly go through with you already how to actually detect it in the exam style, in the exam question. Okay, alright, so you have to detect it yourself because generally they won't give you very clear keyword. Alright, so about the binomial distribution, but you can just look at the structure. Alright, then for geometry also the same thing. So later I will roughly tell you what is the keyword or phrase or sentences that you can look for. Okay, then you will know that it's geometric. Okay, so for geometric distribution, what are the conditions that we have? Just like the binomial distribution, we are having two possible outcomes also. So usually we call it a success and failure again. Okay, and then no fixed number of trials. So this is different from binomial distribution. For binomial distribution, we have fixed number of trials. That means you are having the number n. Alright, but for geometric progression, there's no fixed number of trials, and then the experiment is repeated until a success occurs. So generally, this is the keyword, the main idea for geometric distribution. So we are talking about the number of experiments until a success occurs. So usually you will see this kind of sentence, until something happens, until you get something. So usually that is geometric distribution. Okay, right, then the outcome of each trial is independent of the outcome of all the other trials. So again, it is still independent. That means every single trial will not affect each other. And then the probability of success is P. And then again, the P must be constant, just like binomial. And then Q is 1 minus P, must be also a constant. Alright, so Q is actually the probability of failure. And then P is the probability of success. So you see that for geometric progression, generally, not geometric progression, geometric distribution. Generally, the condition here you can see it is very, very similar to binomial distribution. But the only thing is that geometric doesn't have fixed number of trials, and then we are talking about the number of experiment that we try until a success occurs. Alright, then the rest is more or less the same like binomial here. Okay, so once you know that it is by geometric progression already, geometric distribution already, then again you need to write out a special symbol for it. So the symbol is this one, X is geometric distributed GEO. Don't write G. Okay, so you should write out GEO and then a bracket P. So this is the symbol for geometric distribution. And we have only one parameter here, which is the P. So for binomial, we have two parameters, right? N and P, right? So for geometric, standard one is only one parameter, which is the P. And after that, what is the meaning for the X? So the definition for X is the number of trials up to and including the first success. Okay, so this is usually the keyword or the sentence that you can look for when it is geometric distribution. Alright, so this is a sentence that you need to know. Okay, alright, then the probability of R attempts up to and including the first success occur is, okay, so X equals to R. What is the formula here? So to get the probability for X equals to R, it is R Q power R minus 1, then P. And then after that, for R equals to 1, 2, and so on. Alright, so you will take note of this one. Okay, of course the formula is different already because for formula, for binomial, right, you have NCR, something like that. But for geometric distribution, it is quite simple. You are having Q power R minus 1 multiplied with P. We will discuss about this formula, how we get this formula later. Right, so I want to focus at this part, the value for R. So please take note that when you are having any geometric distribution, the value of R cannot be 0. Can you see that? There's no 0 here. Okay, for binomial you have 0, right? So for geometric distribution, there's no 0. Why? Later I will tell you. Okay, then after that, you will see that the value of R has no limit. Okay, for binomial distribution, your largest value of R is n, the number of trials. Okay, and then for geometric distribution, you see that there's no limit here. That means your R can go until infinity. But must be integer lah, like 100 lah, 103 lah, and so on. Definitely can. Alright, okay, so this is a very small difference again between the geometric distribution and also the binomial. Alright, so maybe we can discuss about the formula here. Okay, and also the value here, like why there's no zero and then why there's no limit. Okay, so we take a very simple, very simple example, right? Okay, so let's say, take an example, maybe I throw a die. Okay, until 6 occur. Okay, until, okay, wait now. So when I throw a die, I want to seek for the, I want to get the number until 6 occur lah. So let X is the number of trial, the number of throw, up to and including 6 occur. Okay, so let's say I define my X as the number of throws that I get, okay, up to and including 6 occur. Okay, so this kind of sentence again tells you that it is geometric distribution. Therefore, when you want to get the idea right, so you should write all X is geometric distributed, and you need to put in the value here. So what's the value of P? So what's the probability for you to get a 6 when you throw a die? Okay, so to get a 6 when you throw a die, the probability is 1/6. Alright, okay, so X is the number of throws. Alright, so now don't look at the formula and everything, you just focus on using common sense, okay, to get the answer. So first one, if let's say I tell you I want to get the probability X equals to 0, will I get the answer or not? So can you imagine X equals to 0 means that the number of throws. So if let's say when you have X equals to 0, that means you didn't throw the die, you already get a 6. Is that possible or not? No, right? Okay, so based on this common sense, you should know that the value here, X cannot be 0. Therefore, the R here cannot be 0. There's no 0 here. Understand or not? Because you must at least throw the die once, then only you can get some probability. Understand what I said? Okay, then now let's continue. So this is the reason why we don't have any 0 here. Right? Okay, then now, how about if I move on? Okay, if let's say I want to get the probability X equals to 1, so that means I throw the dice, and the first time, I'm very lucky, I already get 6. Okay, so when you throw the die and you already get the 6 for the first time, it will be 1/6. Okay, then if I continue, how about if let's say I throw the die 2 times, only I get a 6. So that means first time I didn't get a 6, second time only I get a 6. Alright, so if let's say first time I didn't get a 6, what's the probability? I get other numbers, right? So what's the probability I get other numbers? So it is 5/6. And then the second time you get the 6 itself, so the probability is 1/6. Alright, okay. Then now, how about if let's say maybe my luck is so-so, then I throw 3 times, only I get the 6. So when I throw 3 times, the number of throw is 3. That means first time I get other numbers, which is 5/6. Second time throw the die again, I still have other number, which is 5/6. And then the third time, I get 1/6 already. Okay? Then I hope that you already can see some pattern. Alright. Okay, so now, if I make this as a P. P means the success probability. Okay, so for x equals to 1, the answer is P. Okay, then for x equals to 2, you'll see that it is Q power 1 and then P. Okay, then when you go to the third one, it will be Q squared and P. Okay, so what is the relation between the formula and also the number here? So you see, when x equals to 1, you have no Q, right? It is actually Q power 0. Okay? Then when you have x equals to 2, you're having Q power 1. So the power here is actually minus 1 from the x. So x equals to 3, that means you're having Q power 2. So can you actually give me a very general formula? If let's say I'm having x equals to n, that means you want to throw it n times only, you can get a 6. So it will be what? Q power minus 1 power p. Or better, I use r so that I can get a formula that you have. Okay, so when you're having x equals to r, that means what? That means q power r minus 1 times p. So this is how we get the formula actually. So if you cannot remember, you can use common sense, okay, to help you and to visualize it, so know how the formula comes. All right, so this is some very basic idea on geometric distribution. Okay, so this formula is important, of course. All right, so you need to use it quite frequently. So make sure you know. Okay, you think a way how to remember it. All right. Okay, then now we continue further before we answer the question. Okay, so now how about the mean and also the variance of geometric distribution? Okay, so for the mean, you need to memorize it. The formula is 1 over p. Okay, so this one, you just memorize it because the proving is actually quite long. All right, so if you are interested, you can go and search online to look for it. Okay, all right, so this one I think you should remember, you should memorize it. Okay, and then after that for variance. Okay, so for variance, I put it here. It is just for interest only, for extra information. It will not be asked in the exam. Okay, but you can just try to memorize it. I think maybe some of the question in the example I include this, but again, it will not be asked in the exam. But mean will be included. Okay, then the next one, you have the mean and variance, and also what is the mode? Mode is always equals to 1, no matter what is the p value, the value of p. Okay, always equals to 1. The highest probability is when you are having the experiment once. Okay. All right, so this is generally what you need to know for a geometric distribution before you start answering question. Okay. Right, so we can start with some simple example first. Okay, let's have a look for example 23. Okay, so example 23 again is a very simple example. So you're having x is geometric distributed, and then they want you to find all these distribution. Oh, sorry, all this answer, all this probability. Okay, so we start with first one, which is very simple. All right, so if let's say x equals to 6, what is the probability for x equals to 6? Okay, so you have a look at this one is a p, right? Okay, so the q should be 4 over 5. So for x equals to 6, that means you repeat the experiment for 6 times. Okay, the last time only you get the answer. Okay, only you get the success you want and the success event that you want. All right, so what do I have here is, okay, so for the first 5 times, you're having failure, right? So 4 over 5, 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 and so on. So it is actually 4 over 5 power 5. And then the last time only you get a correct answer. The success trial that you want, so it's 1 over 6. Sorry, it's 1 over 5. Okay, so it is actually q power 5 or q power r minus 1 times p. Okay, so you should get the answer 0.065536, and then please keep it in 3 significant figures. Okay, so I hope that you can answer this. You can get the answer here. All right, so it's a very simple example. Okay, then let us have a look for the part B. Okay, so for part B, they They want you to calculate the probability for x smaller equals to 2. So again, smaller equals to 2, what's the value that you need to include? Should I include 0 or not? No. For geometric distribution, there's no 0, right? So you should be having x equals to 1 and also x equals to 2. Okay, so for x equals to 1, what is the probability? You straight away get an answer, right? The success trial that you want, so it's 1 over 5. For x equals to 2 means that the first time you didn't get the success trial, the second time only you get the success trial. Alright, so these are also not very hard. By just pressing the calculator, you should be able to get an answer also very easily. Okay, then how about for the third part? Okay, so for the third part, they actually want you to calculate x greater than 3. So when we talk about x greater than 3, that means you can follow x equals to 4, x equals to 5, x equals to 6 until infinity. There's no fixed number, right? So until infinity. So you don't know what's the infinity that you should include. Therefore, when you are having any greater than x greater than something question for geometric distribution, usually you need to take 1 minus 1. Alright, so 1 minus what? 1 minus x smaller equals to 3. Okay, so again, the step here might be a bit long, but you might just try first. Okay, so you're having 1, then minus what? Okay, so minus p x smaller equals to 3. That means you start from x equals to 1. There's no 0, right? So x equals to 1. And then x equals to 2. Then x equals to 3. Include the 3, got equal sign. Alright, so you have to write out the steps slowly. Okay, so for x equals to 1 means the first trial you already get the success event. So it should be 1 over 5. Second trial only you get is 4 over 5 multiplied with 1 over 5. And then the third one is 4 over 5 squared and then 1 over 5. Okay, so again, it is not hard at all. The step is okay lah, not really long, right? So you can try and see what's the answer that you get. Okay, so you should get 64 over 125.